Hey everyone, in the last video we unboxed the MacBook Pro 16-inch. Today, I'll be taking you through how I set it up for my daily work. Now in the last 6 months, my focus has been heavily shifting into Python and AI engineering, along with keeping up with my roots in Java backend services and Spring Boot. Because of this, I require a machine that can seamlessly handle everything from local large language models to complex backend microservices. I don't like a cluttered machine. Because of this, we'll be keeping the setup minimal, clean, and optimized. If you're setting up your own machine or are just curious about the utilities that I use in my day-to-day tasks, let's open up a terminal and let's get started. Okay, so the very first thing that we need is a reliable package manager. On Mac OS, that tool is Homebrew. It allows me to install, update, and manage almost all of my developer utilities directly through code without dealing with any of the random installers. To set it up, you just have to select the string from the brew.sh setup. Paste it right here in the terminal and press enter. It will ask for your Mac's login to authorize the system pathways. Go ahead and type it in. The terminal won't show any characters while you type for security, so just type it and hit enter. Once it finishes running, pay attention to the bottom of the screen. Homebrew will give you two next steps commands to copy and paste. Running those ensures that your system always recognizes the brew command whenever you open a new window. Next up, let's install a browser. While Safari is great for conserving battery when I'm traveling, I need a browser that can help me with all the developer tools that allow me to debug and view my documentation seamlessly. My preferred choice is Brave or Helium. I personally prefer Helium because it completely supports uBlock origin. Now instead of going to any other package manager, we just type brew install Helium browser. Now this command automatically fetches the exact Apple Silicon version, mounts it and puts it straight into your applications folder cleanly. With our browser ready, let's next get onto Git. We need to configure Git right away so we can securely pull and push code. macOS has a baseline version of Git installed, but we want to make sure it's globally mapped to our identities so we don't need to hit any authentication roadblocks later on. In the terminal, type git config global user.name followed by your name in double quotes. Right below that, type git config global user email with your primary email address. If you want to double check that your details are saved perfectly, type the git config list. That would take you to your list of configurations that are there for the global git configuration. This takes less than a minute but saves a massive amount of time down the road. Now, since my daily workflow involves bridging the gap between enterprise backend systems and deep learning and AI pipelines, I need both Java and Python to coexist perfectly without breaking each other. For Java development, managing different JDK versions for older or newer Spring Boot applications can get messy. To handle this, I'll be using a lightweight tool called SDKman. We pull down their quick installation script using the simple curl command. Once it initializes, downloading an isolated optimized version of Java is as simple as typing SDK install Java 21 open. Now this will install the OpenJDK version of Java. Now that Java has been installed, let's get on to our core AI workflow, Python. In the past, everyone has installed Conda or MiniForge, but as a developer, I want my tools to be quick and instant. So we'll be using UV. It's the next generation Python package manager written in Rust. It replaces pip, poetry, Conda, everything in one single binary. For this, I'll be doing a brew install UV. Now watch the speed. We don't need to manually download any Python installers. We just need to tell UV to create a new project with the exact version of Python we want. If I type uvvnv Python and the version that I give it is 3.11, boom, it's done in less than a second. It fetches a native Apple Silicon version of Python 3.11 and creates a virtual environment with it. Now let's activate it. With our Python environments isolated, let's move on to a workspace that can help us write, read, and evaluate our code, and also help us with the documentation and visualizing the data. Up until now, my usual preferred choice was IntelliJ or VS Code, but lately I've started to move on to Zed. It's the next generation IDE built on top of Rust, which gives me raw performance, so I rely on this one. Let's install it. Most people download VS Code, even I used to rely on it earlier, along with IntelliJ as a second option. But VS Code is built on Electron, which can feel heavy and eat up memory. Since I'm on a high performance MacBook Pro 16-inch, I want an editor that matches that raw speed. Once Zed opens, notice how it instantly reads our local folder tree. Now let's open the command palette and ensure that our Python environment is selected. Zed has built-in native support for Jupyter notebooks, so you don't need to install a dozen of separate extensions like you do in VS Code. It just works out of the box. Let's spin up a fresh blank IPyNB file right inside the Zed to test our machine learning stack. We will type out a quick 3-line script just to see if the PyTorch works with MPS. That's the metal performance shaders. Perfect. By using UV and Zed together, we have completely stripped away the lag. Our data pipelines, local deep learning tests, and RAG architectures run directly on the Mac's unified hardware graphic cores using Apple's metal performance shaders. So the next layer of my development stack involves containerization API testing. For container management, we are installing Docker Desktop. When downloading this, make sure that you explicitly verify whether you are selecting the correct version labeled for Apple Silicon. Docker on macOS heavily relies on the hypervisor framework libraries, meaning the containers that you spin up, either it be PostgreSQL database for a backend or a vector database like ChromaDB for AI agents, they will spawn up in a matter of seconds without placing any heavy thermal load on your machine. Once Docker Desktop is running quietly in the background, we need a visual way to construct, test, and debug our API endpoints. For this, I'll load up Bruno. It gives me an absolute baseline dashboard to structure HTTP requests, inspect JSON responses from my applications and controllers, or test real-time streaming connectors coming out of custom Python backend layers. So as an engineer, writing the code is only half the battle. Managing your thoughts, tracking your progress, bugs, and even structuring your learning roadmap is equally important. For my day-to-day note-taking, project documentation, and tracking my learning goals, I rely heavily on Notion at the moment. We can pull this down easily with brew install cask Notion. It is where I keep my database of thoughts, daily engineering tasks, and even my learning roadmap. However, since I've shifted to AI engineering, I have been researching local first workflows. I'm incredibly curious about this tool called Obsidian. Unlike cloud-based apps, I know Obsidian stores everything as local markdown files. These files rely on your hard drive, which opens up amazing possibilities for linking ideas together visually. I have seen a beautiful graph being created out of it. I'm planning to try it out over the next few weeks to see if it fits my system better. If you already use Obsidian for any of your workflows or even learning roadmaps, do let me know what are your favorite plugins in the comments. Finally, the last tool in my technical workflow stack is OpenCode. OpenCode is a completely open source, terminal-based native AI coding agent framework. While I use Zed for my manual programming and running Jupyter notebooks, OpenCode is the tool I would use when I want to run an AI agent to actually execute tasks, scan repositories, and refactor code directly inside of my shell window. Let's install it using the automated curl script provided on the OpenCode's website. Notice how it launches in a highly responsive terminal dashboard. What makes OpenCode a game changer is the vendor freedom. I can connect to over 75 different LLM backends. You aren't locked into the typical Anthropic or OpenAI subscriptions. You can route it directly to free open models or even run one of your own locally. And that's pretty much it. With a few simple clean steps, the MacBook Pro is fully configured into the exact workspace that I will rely on every single day for my software engineering and machine learning and deep learning workflows. I have kept it clean, intentional, purpose-built with this environment so that I can easily switch between core backends and deep learning and machine learning tasks. Now that our environment is completely set up and optimized, we are ready to shift our focus onto building. In the next video, we will be shifting our focus heavily towards the model deployment side, wherein we will be able to deploy our own local models for local AI inferencing. In that video, I'll be covering how we can deploy our own models and connect to OpenCode, the coding agent that we installed recently. This will include using OpenCode to perform planning and agentic tasks using local AI models. Now, since the MacBook Pro has 48 GB of unified memory, I will see what all models are possible to be deployed on this particular configuration. Now, this will allow me to completely run everything entirely offline with the maximum hardware acceleration. Now, if you found this step-by-step layout helpful, make sure to hit the like button and subscribe to follow along through the journey. If you encountered any of the roadblocks while installing any of the tools mentioned in the list, do drop a comment to let me know so that I can help you debug them. Thanks for spending some time with me today. I'll catch you guys in the next one. Thank you.